Hi, we're going to find the endpoints of one array in another array. So, here's the thing. APL has a primitive function built in which finds the beginning points. This can be a little bit hard to visualize, so I'm going to stack Mississippi here on top of the Boolean result that we get, spreading out the letters. Here we can see that we're searching for Issy, and we're finding that it begins here and it also begins here, stretching towards the right. The result that we want is with the ones being here and here, meaning where they end. There are basically two easy ways to do this. One of them is to note that we already have these ones in the right relative locations, but they're just offset from where they're supposed to be. We need to move them towards the right. By how many steps? Well, it has something to do with the length of the match. But if we were to move 4 steps to the right, then we would end up one beyond the match. So we need one less than that. Okay, let's just try this. So we're going to take this primitive and we're going to wrap it in a lambda, so it makes it easier to change its result. And we can rotate with the rotate function. And well, that rotated 1 step left. To rotate right, we want negative numbers. Okay. And then we said that it has something to do with the length of the left argument. What happened here? Oh, this is again to the left. So now we want to negate this so that we are moving towards the right. Okay, so we can see that we got the Issy here, but the one is now 1 step too far. So really, we would want to subtract 1 from this. We can add -1 to the length, and that gives us the result we want. But we can actually simplify this a bit, because subtracting 1 from a number, or adding -1 as I've done here, and then negating it, that's the same as subtracting that number from 1. Oops. Subtracting that number from 1, right there. Here we go. So this formula will work. We can reduce the amount of code a little bit by observing that we've got kind of a fork construct. What do we mean by a fork? That means that we have a middle function here that takes the result of something in the terms of the arguments and something else in the terms of the arguments. So we can change this to a tacit form, changing the curly braces to round parentheses, and then we can remove the explicit mention of arguments. Over here, we do need to refer to the left argument, and we could do that using just functions to make it fully tacit. But we can also just make this inner expression into a function. So here we have a small lambda that's applied to both arguments, ignoring the right argument, only using the left argument, and returning 1 minus the length of the left argument. And that value is used to rotate the result of the find primitive, which shows us the beginning points. And this gives us the correct result. So we can take this whole function here and give it a name. Nope, missing that brace there. And then we can write a left argument and the right argument, and we get our result. So this is one way to do it. Another way to do it is to observe that the find function gave us the beginning points. But if we read from the right instead of from the left, then that's actually the end point. Doesn't matter that what we're looking for here is a palindrome. It's still finding that from the left and then if we read it from the right, we get the endpoints. So if we reverse both arguments, we could do that with the over operator, which preprocesses both arguments with reversal. And for ease of comparison, let's also indicate what's going on over here. So let's reverse that as well. So if now we can see that we are looking for the beginning points, but if you're reading in reverse, that's actually the endpoints. So the only thing that's missing then is reversing the result. And now we've got the endpoints. Can give this a name, and then we can apply it like this. That's another solution. Thank you for watching.